All right. Hello. Hope you're all doing okay today. We're going to go over something else related to the AI practitioner exam. Remember to like, subscribe, share this to anyone else you know who might be taking that exam. Today's lesson is going to be on prompt engineering. Okay. We're going to do that within the AWS console. So, what is it and how is this important? So, prompt engineering is crucial for optimizing the performance of large language models, LLMs. It involves creating, refining, and optimizing prompts to ensure that the output aligns with the user's needs. Mastery of this skill is essential, not just for the AWS certification exam, but also for working with various LLMs like ChatGPT, Claude, and obviously AWS's Bedrock and their SageMaker platform. So, what are the components of an effective prompt engineering situation? One, you need the instructions. You have to define the task clearly for the model. Instead of simply saying, "What is AWS?" specify something else. Quote, write a concise summary that captures the main points about AWS, focusing on key services. So, what we'll do is I'll show you on this. So, instead of the following, what is AWS? Let's add a question mark there. Let's try something else, like write a concise summary that captures the main points about AWS, focusing on key services. Okay. This is vastly different. It asks for specificity of the platform, what it does, why. Okay. Context. You have to provide external information that can guide the model's output. So you can do this for an example. All right. Oops. I'm teaching a beginner's course on AWS, so the summary should be simple and easy to understand. Context. Then input data. With this, you provide the data that the model should base its response on. So you can provide a passage or an article about a specific AWS topic or the platform in general for the model to summarize. And then you have an output indicator. So this is where you want to specify the format or the type of output you expect. It could be tables, it could be charts, you could have line graphs, you could have text with bullet points. There's a bunch of different ways you can do this. So an example would be the following. Provide a 2 to 3 sentence summary. That's a very simple way. By integrating these elements, prompts become more detailed and focused, leading to more accurate and relevant outputs. Then you have negative prompting. So, negative prompting explicitly tells the model what not to include in its response. This technique helps with unwanted content, it maintains focus on the relevant topic, and enhances the clarity of the output. So, for example, you could say a prompt like this. Avoid discussing technical configurations specific to AWS tutorials or personal learning experiences. So adding this to the prompt ensures that the model avoids including irrelevant details, leading to a more precise response. So you have to practice prompt engineering. There's basically naive versus enhanced prompt. A simple prompt would be something like, write me a travel itinerary. Okay. That's fine, but it'll yield a very basic generic response. A well-structured prompt would have detailed instructions, context, input data, and output indicators. This can guide the model to produce a much more tailored and useful itinerary. So a negative prompt example would be to add restrictions like the following. All right. For that itinerary, you could add this, write me a travel itinerary. Do not include activities primarily for children or families. Sounds like it's for a single person. Okay. So here's some advanced things when it comes to prompt engineering. Okay. Prompt engineering matters for your IT career because it has strategic importance. Okay. With consistency in this, you can ensure predictable AI outputs for automation and monitoring. Regarding security, you can prevent prompts to inject attacks and unintended data exposure or exfiltration. You can have compliance, or you can create auditable prompts that meet regulatory requirements. Remember that HIPAA, GDPR, PCI, DSS, PII, cost optimization. You can reduce token usage through efficient prompt design. And then quality assurance. You need to make sure your output standards are standardized across different models and use cases. Next, you have to optimize your prompt performance. So you have to understand the text generations. LLMs generate text based on probabilities assigned to a possible next word in a sentence. So adjusting parameters like the temperature, the top P, and top K can influence the creativity and coherence of the model's output. So here's some key parameters. System prompts. These direct the model on how to behave or reply. So an example would be, let's see, if we can get this. System prompts, let's see. Reply as if you are a teacher in the AWS cloud space. Okay. Temperature. This controls the creativity of the output. A low temperature, like 0.02, the outputs will be more conservative, more predictable. A higher temperature, like a 1, so on a 0 to 1 scale, the outputs are more creative, but maybe less coherent. So think of this as a 0 all the way to 1. Okay. And in this, you have 0.1. And a little bit over, you might have 0.5. And all the way over here, you'll have a 1. And somewhere in there, you get to control the temperature. Low, high. All right. I hope that makes sense. All right. The top P. Top P. So this determines the cumulative probability of the most likely words considered. So a low P, like a 0.25, would restrict to the most likely words, leading to more coherent responses. A high P, like a 0.99, would allow more diverse word choices, increasing creativity. So again, it's at 0 to 1 scale, right? Low creativity. And then over here, high creativity. All right. So more conservative versus, I'm sorry, probability. Sorry, a low, most likely words. Okay. Sorry. Let me update that. Most likely would be more accurate to say that. More diverse. Okay. So that's for top P. My apologies. All right. Now you have top K. Okay. This limits the number of potential next words. So again, on that 0 through 1 scale, okay, a low K, a 10, so this is a different scale, would consider fewer options, leading to focus on more coherent responses. A high K would lead to more options, increasing the diversity of the output. So more coherent. All right. And over here, you would have more diverse. All right. And then you have the length and stop sequences. With this, you can define the maximum output length and specific tokens that signal the model to stop generating text. All right. So why does this matter? Different models require different parameter configurations. Proper parameter tuning can reduce costs by 30 to 50%. So consistent parameters ensure reproducible results for any automation with your IT department. All right, so how do we implement this? Let's go to the AWS console. Let's go to Bedrock. All right. Let's go to Playgrounds. Chat the text Playgrounds. Okay. And then we're going to select our model. Chat, select the model. Let's go Anthropic. Let's go with Claude 3.5 Sonnet. This is good for a consistent result. This is a long-lived. All right, so what we're going to do is configure the base parameters. So first we're going to set the temperature. All right, we're going to set it to probably a 0.2. So it'll be more factual, more technical content. All right, now remember, if you set it to 0.7, 8, 9, it's going to be a lot more creative. Okay, so we'll set it here. Okay, and then top P. we're going to go for more standard. This is going to be good for most use cases. We're going to set it to about 0.9. Oh, 0.9. Let's go 0.9. Okay. And then top K. We're going to go for more balance, diversity within this. So out of a, see, 0 to 500 scale, set it about 260. Let's go a little bit over. All right. So then we're going to have the maximum length. So we're going to set this at 512 tokens. This is just for testing. And then we're going to have some stop sequences in here. All right. This is going to be for structured outputs. Okay. The hashes, and then a couple of dashes. All right. We're going to add those. And then we're going to do a test parameter. All right. A base prompt for this. Give me a second. And we don't need any guardrails. We went over that in a previous lesson. We're just doing this for a run. So explain at AWS IAM best practices for a security team. This is going to be a pretty short one, pretty technical, not too creative. Okay. So this is goes through this. IAM is a crucial service for managing access to AWS resources securely. Here's some best practices. Principle of least privilege. IAM roles instead of IAM users. Strong password policies. Use groups to manage positions. Permissions. Regular audit IAM users and their permissions. Rotate access keys regularly. Use IAM policy conditions. Avoid using the root account. Enable CloudTrail logs. Use organizations for multi-cloud management. These are very solid, and this is pretty brief. Here's your this is your 512 token output, and you should be solid, right? So we could do something else. Let's raise the temperature all the way to 1, and let's run it again. Okay. Oh, oh wow. Let's try this one more time. Let's see if this is good. Okay, so it's a little more brief. No, no, it got it pretty securely. Okay, it's pretty similar. I'd have to probably juice this or ask them a little bit more crazy of a question, but they got pretty good. All right, the latency was there, but that's okay. We still got this. All right, so how do you want to implement a structured prompt component? Okay, so with structured prompts, you can provide consistent measurable results. This helps you enable automation and integration with your CI/CD pipeline. This would support audit trails for compliance requirements. So you could have a multi-prompt component structure. All right. So let me give you a template that you can use, and you can input your information. Okay. So you have instructions, right? And you want to make sure you have your spelling pretty good. Instructions, colon, name the first 15 presidents of the United States of America. Context. So this is relevant background information. I need to see which ones were taller than 5'6". Let's say 5 feet 6 inches. Okay. Input data. All right, let's try this. Input data. Okay. Table of US president's height. This can help. Okay. Well, we don't, oops, I want to copy that, but that's not what I want to do. Okay. So we'll hide. Yeah, this will be good. Okay. This is good. Okay. Now, I hope this is going to be able to contain all of this. Sometimes the context window is not large enough. All right. Output format table with name, height, and age of, and year of year they were elected. Okay. All right. Let's see what this got. Okay. So here's a table with the first 15 presidents of the United States, their heights, and the years they were elected. All right. So it listed these all out as we wanted. Oh, the only it didn't leave out James Madison because I knew he was a shorter gentleman. Did I ask? I need to see which ones were taller than 5 feet. Okay. I could rewrite this. Let's try this. Okay. Instruction. Name the first of America and highlight ones shorter than 5 feet 7 inches. Okay. Let's confirm the edit. And highlight in bold and italics ones shorter than 5 feet 7 inches. Let's try this now. All right. So now you see, okay, James Madison, 5'4", and the year elected, Martin Van Buren, 5'6", born in 1836. All right, and then you see a note: John Tyler and Millett Fillmore became presidents by succession, not election. Their heights aren't included for completeness. Okay, that's even more than I asked for. So you could actually remove that information or have it highlight that information. Okay. So you can use this and make reusable prompt templates so that your security team could have something very specific. So you could have something to analyze the security configurations of your VPC, have it identify what user data scripts are being exposed, or being used, have it do something like report back if there are any public IPs that are available, right? There's a bunch of different things. And you could have it list out in an output form with a table that shows high risk, medium risk, low risk, or any other things, along with recommended remediation steps. So think about prompt engineering as a way to speed up and rearrange or revolutionize your workflow. Okay, so remember to have your templates available. Remember to update your input data. You can use something like an IAM policy. Then verify the output meets the specified format and your desired request, and document the response quality and consistency. That's going to be crucial for any of your teams. So there's also different ways to go about this, right? You have zero shot prompting, right? Let me spell that out because sometimes I'm not pronouncing things well. Okay, we'll go back over here our text document. All right, so zero shot prompting, or let's go to the next page. Zero shot prompting. All right, so what is this? This is presenting a task without providing any examples. It relies entirely on the model's general knowledge. So, okay, let's do something like this. Write a one, write a funny one paragraph story about a penguin. Okay. And here we go. Percy the penguin always dreamed of becoming a world-class surfer, despite the obvious challenges of living in Antarctica and having no arms. Undeterred, he spent months sliding down icy slopes on his belly, perfecting his technique. One day, he decided to make his debut at the local penguin colony's annual ice fishing competition, mistaking it for a surfing contest. As he waddled up to the edge of an ice hole, flippers spread wide, he shouted, "Cowabunga!" and belly flopped into the frigid water. To everyone's surprise, his unorthodox entry scared so many fish to the surface that he was crowned the accidental champion, leaving the other penguins both confused and impressed by his radical fishing skills. That's a funny one. That is good. All right. And then you can have few shot prompting. Okay. Few shot prompting. All right. So this is where you can provide a few examples to guide the model's output. This technique ensures that the model's response aligns with the desired format and content. Okay, so let's go back over here. All right. Okay. Write a funny story about a penguin. Please don't mention surfing, but mention how they love only once in a lifetime. Okay. Okay. Polly the penguin was a hopeless romantic, fully embracing the fact that penguins mate for life. She spent years waddling around Antarctica looking for her soulmate, leaving a trail of fish scented lovers in her wake. One day, she spotted a dashing figure across the icy expanse, and her little penguin heart skipped a beat. She slid on her belly at top speed, practicing her best pickup line, only to realize halfway there that her dreamboat was actually an oddly shaped black and white rock. Undeterred, Polly decided this was a sign from the universe and promptly named the rock Rocky. She now spends her days snuggling up to her stoic partner, regaling nearby penguins with tales of her whirlwind romance, much to the amusement and confusion of the entire colony. Didn't mention surfing, did mention loving once in a lifetime, and pretty humorous. Okay. And then there's the next model. Okay. Chain of thought prompting. Okay. So this is where you can break down a task into sequential reasoning steps. This encourages the model to think and respond in a structured manner. So you just describe the setting, then the characters, and then introduce whatever you need to. Okay. Describe to me a penguin. Where would it live? How would it feed itself? How would it reproduce? And who are its natural predators? Please limit this to one paragraph. Okay. The penguins are flightless seabirds known for their distinctive black and white plumage and waddling gait. They primarily inhabit the southern hemisphere with species from Antarctica, sub-Antarctic islands, South America, Africa, Australia, and New Zealand. Penguins are excellent swimmers using their flipper-like wings to fly underwater in search of food. Their diet consists mainly of fish, squid, and krill, which they catch using their sharp, pointed beaks. Penguins reproduce by laying eggs, typically one or two per clutch, which both parents take turns incubating and caring for after hatching. Most penguin species form monogamous pairs for the breeding season or even for life. Their natural predators vary depending on their habitat, but generally include marine animals like seals and orcas in the water. While on land, they face threats from birds like squaws and giant petrels, as well as introduced predators like cats and rats on some islands. I think that was pretty accurate. And I broke it down into a series of responses that were accurate towards it. And then you have RAG. This is retrieval augmented generation. Okay? RAG. So this combines the model's capabilities with external data sources and enhances the model's responses with contextually relevant information. So you could, with this, you can provide additional information about the behavior and common mysteries and ask the model to write a story incorporating these details. So let's go penguin details. That's gonna be AI. Okay, let's do this. City of Albuquerque. Yeah, let's do. Let's just copy paste this. Okay, let's go over here. Please update this story with the details in this text. Please update this paragraph. Be accurate. What did I just press? Why is this not paragraph? About this? Please update this with the details in this text. So it would be a few shot prompting, but it would use external data sources. You could also use a website if you have a model that can access that, but that's a different estimation. Okay. So here's an updated version, details of both texts. All right. So here we go. Penguins are flightless birds, known for their distinctive black and white plumage, which serve as a clever camouflage called countershading. They primarily inhabit the southern hemisphere, found in Antarctica, subantarctic islands, South America, Africa, Australia, New Zealand, and even the Galapagos Islands. Penguins are excellent swimmers, using their flipper-like wings and rudder-like feet to fly underwater in search of food. Their streamlined bodies and solid bones, unlike other birds' hollow bones, make them perfectly adapted for aquatic life. Penguins feed mainly on fish, squid, and krill caught with their sharp beaks. They reproduce by laying eggs, typically one or two, which both parents incubate and care for. Most species form monogamous pairs, with males often wooing females by giving rocks for nest building. Penguins gather in groups called rafts in water, waddles on land, or huddles for warmth and protection. Their natural predators include marine animals like seals and orcas in water, and birds like squaws on land. Penguins maintain their waterproof feathers with oil from a special gland, spending hours each day on this essential grooming task. So that did add some character to this. Okay. So this provided additional information about the penguin and asked the model to incorporate the details. All right. So let's go into a little bit more. So zero shot versus few shot. So zero shot is best for general knowledge tasks. One, it's going to have fewer tokens and it's going to cost less. Few shot. This is good for a specific format and a domain specific task. So if you want to know something about penguins, that would be very good. Okay. And then you have to figure out how are you going to maintain a consistent output quality in your code. Okay. What does that mean? Having a prompt. Let's try this one. Generate a Terraform configuration for an S3 bucket with versioning enabled, public access blocked, and server-side encryption with KMS. Okay, so what are we going to do? We're going to lower this temperature down to 0.2. We want it to be very rational, right? Very consistent. We're going to have the top P, let's have it at 0.95, okay? And the max length, we'll have it at 1,000 tokens, okay? Let's run that. Okay. Now this looks pretty solid. Okay, you have the provider for US West 2. You have the KMS key for the bucket to encrypt it. You have the S3 bucket, secure. Replace that with your name. You have the versioning for the bucket, which we asked for. And then the ACLs for the bucket. Block them. Block any public access. That's fantastic. That makes it more, that means it's secure. And you have the server-side encryption with the KMS key. That is great. So you set this up with your AWS provider, the key, buckets with the name, enable versioning, block all public access, and server-side encryption. So you can save this, yep, to s3bucket.tf. Yep, that sounds great. Terraform init, Terraform plan, Terraform apply. And then yes, and this also makes a suggestion to update the name with your desired name and adjust the regions. I think this is a great zero-shot answer. All right, so here's going to be um, let's see, we're going to find. Okay, let's go find this. Okay. All right, we're going to use sample findings. Hmm. This would be good. Okay, we're going to use this. All right. So I grabbed this. I have some of this already prepared. Okay. Oops. I shouldn't have done that. Okay. So here are examples of security findings. All right. And then we're going to find sample one. Now analyze this configuration and output recommendations. All right. So we found some PCI DSS. All right. This is going to be credit card information, payment information. We'll see what this outputs. All right. Based on the security findings, here's some recommendations. Based on this, encrypt the CloudTrail logs. CloudTrail logs are not set for this because, let's see, you have CloudTrail right here. All right. Implement least privilege. So KMS keys, multi-region, CloudTrail trails to be tracked. Set up CloudTrail logs. This is good. Integrate this with CloudWatch for real-time monitoring, retention archives. Enable MFA on the S3 bucket. Ensure this CloudTrail configuration. So you can get a lot out of this. So you have your product fields, security hub. This is the monitoring subscription, control ID for CloudTrail, config rules, security hub cloud encryption, CloudTrail encryption, security hub CSPM. So this contains some good information for that, right? And this was sampled to provide an example of a finding for a control that applies to payment to PCI DSS based on CloudTrail, right? Or how you can find that through CloudTrail. And this made 10 suggestions in order to remediate this situation. Okay, so with this, you could also get the information further down, right? Around AWS resource tagging, which would also be useful. So this would be a different type of query, or I'm sorry, a same query, but with different types of data. Tags would be handled differently than something like your PCI DSS. So you want to make sure that you're able to use standardized inputs to get regularized outputs for your future tracking in your workflow. All right. And then document the accuracy over time. Measure your token usage difference and choose optimal approaches for each use case, whether that be your tags or your CloudTrail or your PCI DSS. It can help you on your job. All right. Next, you have chain of thought. So chain of thought improves accuracy for complex reasoning tasks, and it provides an audit trail for any AI decision making. And it's really essential for regulatory compliance in something like the financial services or something along the lines of healthcare, making sure you're tracking this. Okay. So you could have a standardized template for doing this. Okay. Let me get example. Let's see. Let's try this. Get. Let's see if we can find a good example. All right. All right. We're going to try this here. It's going to be a 6 steps, right? Using this IAM policy. Okay. So we're going to say, analyze this IAM policy step by step, identify the principal, list all the actions permitted, determine resources affected, check for condition statements, assess overall risk level, recommend improvements for this. Okay. We're going to run this. All right. So it lists, it so doesn't specify a principal, lists all the actions permitted, create user, tag user, explains it, check for condition statements there too, string equals if, for all values, string equals. These conditions restrict the tags that can be applied when creating or tagging users. Step 5, assess the overall risk level. It allows creating IAM users, which is a powerful permission, and you can start adding outputs. So to rank it on a 1 to 10, one being safe or one being risky, 10 being safe, 10 being risky, right? Restricts the tags, which is a good security practice, doesn't allow modifying existing users, and then recommended improvements, right? Narrow the scope, narrow the scope, narrow the scope, consider splitting it into two statements, add a condition to restrict the number of users, implement a naming convention for users, add file trail logging, regularly review and audit, consider organizations and SCPs. Okay. I think this is solid, right? So this would be a pretty complex scenario to break down. And AWS does have something like this with IAM Access Analyzer. But if you needed something more custom for your specific environment, this would really help. This can be a complex security scenario, a compute scenario, operational scenario, something along the lines to make your workflow better, right? And then you can compare this with what you already would know and then have a direct question for follow-up if necessary. But then you can have series of questions to get series of outputs. And then you can document the reasoning quality over time and create a good workflow for how you can use AI. Okay, negative prompting. Let's go in a little bit more about this. Okay, so negative prompting prevents generation of sensitive information, ensures compliance with data handling processes, and reduces the risk of inappropriate content in production. Okay, let's see. All right, so let's see. Let's see. Explain how to secure an AWS environment. Do not include specific password, API keys, or detailed vectors. All right. And then verify output excludes sensitive information, PII, count, number, ARNs. Oh, you can keep ARNs. Inappropriate content, restricted topics. I think that would be safe. Okay, we'll click run. And here comes some good steps. All right, so use IAM to act for access control, least privilege, roles, MFA, audit and rotate keys, network security, use VPCs, and use NACLs, use WAF to protect web apps, enable VPC flow logs, encrypt data at rest, use KMS for key management, monitoring logging, compliance and governance, secure development, edge security with CloudFront, regular updates and patch management, systems manager, incident response with security hub. Likely guard duty would be in there, but this is a very good brief one and an employee training. Right, so this is a high level overview, which it states here, which I appreciate. Okay, and it didn't give out any information or specific passwords, but it did mention keys, credentials, didn't say passwords. That's good. That's good. Because it didn't ask to use specific passwords, but it might have included or inferred that not to mention the word password at all. So that could be a backward way of also addressing that. Okay. Next, you have production prompt engineering. So this is where you have parameter optimization for different use cases. So why does this matter? So different tasks require different creativity levels. Proper tuning reduces costs and improves quality, and it enables automated workflows with predictable outputs. So you need to create a user case parameter profile with technical documentation, right? With that, you would want to keep the temperature very low, right? Keep the P relatively high, probably above a 0.8, and then keep the top K right in the middle. So somewhere in that 200 to about 300 range. So we stick about that 250. Okay. And then you have your stop sequences here. All right. So that's one. Next, you might have creative content. Okay. This could be anything from that story about the penguin we had earlier. So you might want to turn the temperature up 0.6 or above, maybe the 0.8, somewhere in that neighborhood. Have the top P relatively high, so it can still be accurate. Okay. And then your top K, you want to get a little more creative. Let's put it at about the start at 300. Okay. Let's put it around 350. And then the length tokens right here at 1000. And you can add a stop sequence here. Okay. Let's say, all right. Oops. All right. So you have a stop sequence right here. Okay. Then you might want to have something like code generation. It's going to be very deterministic. All right. So what do you want? This temperature is going to be ice cold right here, maybe right here. Okay. And then you want to have the top P a little lower so it can be a little creative, but it can have solid and concise answers. Then you want to have your top K lower. So it's going to be a lot more rational thinking. And then you want to increase your tokens. Okay. So maybe 2000 tokens here. All right. And then you want to have a couple of stop sequences. Say the, I can't remember what these called. Not the they're not tildes. And then and oops. Okay. Yeah, these. So it can end the creation of it. All right. And so with this, you can create standardized test prompts with these randomness and prompt configurations and parameters so that each parameter combination will get you consistent outputs. Then you should document your research and share this in your team's knowledge base and keep a knowledge base for yourself. So with this, you can create automation with optional or optimal parameters. All right. Then you have system prompts and role definitions. Why does this matter? This helps you establish consistent AI behavior across applications and enables role-based AI assistance for different teams. It supports compliance with organizational policies. So how would you do this, right? You would create a role-based system prompt for, let's say, a security analyst. So let's do this. Let's see, that temperature's there. The top P is here. Let's turn the tokens down a little bit, okay? So let's do this. It's going to be something really relevant. You're a cybersecurity expert handling AWS cloud security. You always prioritize security best practices, consider compliance requirements like SOC 2, PCI DSS, HIPAA, and provide actionable recommendations. Focus on prevention, detection, and response strategies. Always include risk levels and business impact. So you can have this in here within your system prompts when you're having a project going on forward. Or you can have an alternative. Right? Oh, sorry, that wouldn't actually be here. That would be here. My apologies. This would be here. Okay. So this is context. All right. And then you could have another one. All right. You're an experienced DevOps engineer focusing on AWS infrastructure automation. You prioritize infrastructure as code, CI/CD best practices, and operational excellence. Always consider scalability, reliability, and cost optimization. Provide practical, implementable, secure solutions with consideration for monitoring and maintenance. This would always be at the back of the mind when this is being pursued. All right. So you can add this prompt to a conversation. You can test the consistency, verify the response. One, because you already know this, but two, you'll be able to track and measure the outputs to see if they're relevant to what you actually input. All right. And then next. So then you can integrate this with existing AWS services. This is going to be big. All right. So there's an API integration with automated prompting. So why does this matter? This enables integration with your CI/CD pipeline. This would support automated security scanning and reporting, allow for consistent prompt execution across environments. So you could create a template library. So how would you do this? Now this is where I'm going to have to check this a little bit. Okay, so where would I do this? Let's see. We'll pull this up. And I'm going to store something else here. Okay, give me a second. I'm going to put this over here. Okay. One. All right. All right. So, oops. Um, where is it? There we go. Okay. Okay, so we're gonna drop this template. Which I'll show you. Okay, prompt template one. Um, now how do I implement this? All right, template, it's prompted, formatted, body. Now this is where I'm going to be a little bit. I'm going to say I am not going to be as wise, for we're all learning here together. Okay, so I do have this. It's in this bucket. Let's upload it. Okay, in the alias S3 bucket. Uh, let's see if this works. Let's see if this works. Identify contents in the bucket. Let's see if this works. This is interesting. Including one name, Bedrock access. I don't have real-time access. Huh? You don't? Let's try this. Let's enter the code. This is what I put in here. Let's see if this. I'll put something. I put this in S3. So, huh? It's interesting. Too many requests. Not doing it. So this is trying to pull this, but it's not working like I wanted. Let's see if this with the additional code will work to do something. It's still thinking. This is good. Using Bedrock, here's a breakdown. So this is a template for doing this. So it's giving me instructions on how I'm not using this correctly, which is good. This is good. So this is a system that sets the AI's role, template using this. So I would need to add this. Now, where would I add this? Export as a JSON, view keyboard structure, streaming preference. Uh, so this is where it gets a little more complex as to how I would use this. But this is okay. You can see that this could be used, but how? It was on Bedrock. Let's go back here. Let's go back a little bit. All right. Cross region. This is the playground. This is why we're using that. That's right. Oh, okay. Okay. Maybe this is okay. Let's try knowledge bases. Create a knowledge base with a structured data store. Ooh, maybe that was it. Maybe. Query engine. No, it wasn't. Create a knowledge base with a vector store. Let's use that S3. Yeah. Okay. Let's browse S3. This is the bucket. Here we go. So we went to knowledge store. Let's try this. Select the next vectors preview. Oh, sorry. And we're going to select text embeddings on demand. Did I use the right one? Let's try the text v2. Okay. Create the knowledge base. Okay. Knowledge base creation with a root is not use it. Oh, well, that's good. At least it's doing that correctly, protecting me from myself. Okay, that's good. All right. Well, essentially, we're close to the end, but the knowledge base would be the primary way that I would start putting this into place. And then if you had that there, you could set up some guardrails, which you covered in our earlier lesson, set up some prompt management. This might be it, honestly. All right, so you can create a prompt. This might be it. Yeah. Yeah. This might be it. Main prompt. Let's try this. System instructions. Yep, this looks pretty close. Okay. And you can have the source with your models, agents, test variables, tools. This might be another way to do this. Um, that's okay. This is a good overview, and I think we're at the end of this lesson, but this is good for people to get familiar with what is available with Bedrock as far as prompt engineering. Getting good at this and getting this into your workflow will make you a more effective engineer. Anyways, thank you for joining me. I hope you appreciate this. Tomorrow, we're going to go into Amazon Q. Next lesson. Outside of that, have a great day. Remember to like, subscribe, and share with a friend. Good luck taking the AWS AI Practitioner exam. Good day.